This video is sponsored by PCBWay. In this video, I'm going to make my RC boat powerful enough to surf behind. Last year I bought this wake foil board in hopes of learning to fly. Fly on my feet, that is. These foil boards are the closest you'll ever get to being able to stand on top of a model airplane and fly around. This is made possible by the fact that water is over 800 times denser than air, so the wing can effectively be 800 times smaller than a normal airplane, and still have enough lift to carry a human. It's pretty amazing. The catch with these foil boards is that they require a lot of practice to learn. I was just barely able to ride it being towed behind the boat, but what I really want to learn to do is pump foil. This is where you generate your own thrust by pumping the foil up and down. It's basically the same principle as a bird flapping its wings for propulsion, except the whole foil is moving at once, rather than two halves pivoting independently like bird wings do. Learning to pump foil from the dock is really difficult because you have to jump onto the board with your feet in the exact right position, and then hope you have enough speed left to get a few pumps in before the board touches down on the water. One day when my friend Ansel and I were practicing, we figured out that he could actually tow me with some paracord, just by running down the dock. This was kind of an aha moment for me because Ansel running couldn't have been putting out more than like 400 watts or so, and that happens to be exactly how much power my propeller test boat consumed. So this made me think, why don't I convert the propeller test boat to a tow boat? And maybe if I can get up on foil behind it, it'll give me more time to learn to pump. Of course, I could just learn by foiling behind my boat, but then you have to tow it to the lake and do all the other crap that comes with a full-scale boat. If this small-scale towboat works like I hope it might, it'll be way more convenient and a quicker path to learning to foil. So let's get started on the build. The propeller test boat used just one of these 5064 200 kV underwater brushless motors, and that was mounted in between the two hulls. My hunch is that I would need a bit more thrust than just one of these motors can provide, so my plan was to instead go with two motors. The problem was, these hulls were initially designed for inboard motors with much smaller propellers, so my solution was to 3D print some add-ons to the back that would position the motors behind the hull while keeping everything as streamlined as possible. I printed these out of PETG on the Prusa XL. The next step was to cut a hole in the hull for the phase wires to pass through, and then I sanded off the paint under where the new motor mounts would attach so that the glue could adhere directly to the fiberglass. This PETG motor mounting part screws directly onto the motor, and then that screws onto the main motor mount part through the sides. I did it this way because the motor mounting screws are on the back, so you wouldn't be able to get to them if it were all in one piece. Next, the phase wires got routed through the hull, and I put Gorilla Glue all over the motor mounts. Then those got stuck on there and clamped in place to cure. The Gorilla Glue foams up a lot, so I bent a razor blade and used it to shave out the corners. That actually worked really well. Next, I just siliconed the crap out of the phase wire pass-through, and then smeared that all around the hull. Here's a Vesk 75100 going in. These are the motor drives I used. And I poured in a little expanding polyurethane foam to make this boat a bit less sinkable. I printed these dangly things out of flexible TPU and screwed them into the back of the hull. Their purpose is to hopefully hold the tow rope out away from the props so that it doesn't get tangled up. This is the waterproof electric skateboard or e-foil controller that I'm going to be using to control the motors. It only has one channel, for throttle control, so we're going to have to figure out how to control steering later. I glued that onto a carbon fiber tube. This is going to be the tow rope handle, and that pretty much concludes the build. Before using it with the e-foil, I wanted to test it out with something a little more stable, like a paddleboard. For this test, I'm just using a normal RC controller so that I'll have steering control with differential thrust.
It's definitely fast. This is terrible. Those props are not submerged enough at all. Oh, this kind of sucks. They're just ventilating. They're seemingly staying fully submerged at lower throttle levels. That's full throttle. We're going pretty quick. I mean, look at that. This is a great reindeer. So it seems I do not have as much control authority as I thought I would have by pulling on the reins. The boat's just turning and I can't stop it. I'm being pretty daring for this being a maiden voyage. I started about 2 miles back that way, and now I've been going downwind all the way into this bay. It does seem that we quite frequently have problems with seaweed getting caught on the props. I know there are better propeller designs than this, but this one is really good for fast boating. Yeah, look at all that. Holy crap, there's a lot of seaweed on there.
So my initial choice of propeller for this boat was Contender 25 from Season 1 of the RC Test Flight Propeller Design Competition. While it wasn't the most efficient propeller, it did have an impressively high top speed. During the competition, it got up to 3.6 meters per second. My hydrofoil board starts flying at around 4.7 meters per second, which is much faster, so that's why I really need to be optimizing for speed here.
Okay, I'm about to figure out if it's likely or unlikely that I'll be able to make it home without running out of battery. 86%, oh yeah, no problem. I wish batteries had infinite power. This is what 1 kilowatt looks like. Finally arriving back to the dock. I think it's been like 6 miles or something like that. Wow, these are not planing holes. It's the next day, and I'm gonna try this with the foil now. My hunch is that it's not gonna have enough power to get me up, but I do have an extra battery in here, and hopefully it's enough weight to keep the propellers underwater. I have a feeling I'm still not gonna be able to turn the boat, but I do have throttle, so that's good. It seems like I can steer it. I don't know what's different than yesterday, because I feel like I couldn't steer it yesterday. Oh, it might have enough power. Come on, baby, come on. Oh, it feels close. It's so close. Well, I think I need to go from a 6-cell to a 12-cell battery. Okay, I'm gonna do some data logging on this Vesk. I'll just put my phone in there. Ah, it's not that much more powerful. Damn, I wonder why. It must be the phase current. I think I'm just maxed out on phase current. Okay, well, let's go look at the data here and see what it says. The power is only getting up to 400 watt, not even 400 watts. So these props just pull too much current. They require too much torque at these slower speeds that it takes to get me pulled up out of the water. So I need a lower pitch prop for more pull for me to get up. Then once I'm up, I'm sure these props would be optimal, but they're not gonna be able to get me up out of the water. I just increased the max phase current to 50 amps. So I'm either gonna get more pull or burn out these motors. I'm so close, I'm so close. Go, go, go. Oh, it's just not quite enough. It's so close though. It's not enough chooch. Maybe if I go downwind. Oh, I'm so close. Oh, I'm up. Oh. Oh yeah, oh yeah, oh yeah, come on. Oh yeah, I'm up. Oh, almost. Woohoo, I'm up. Oh. It worked. There's no way I'm gonna be able to climb up on my feet during that though. Woo! Yeah, now we're cruising. Oh yeah, look at that. Woohoo! Oh, this is it. We're doing it. Yeah. Oh, this is sweet. That boat is hauling ass. Oh, and I'm having to balance with my head. I'm just bobbing my neck around to keep the foil at the right point. Now I'm just worried about these motors burning out because they're way over currented. Oh, now I gotta figure out how to stand up. There's no way, absolutely no way that's gonna work. My glasses were sinking and I just barely grabbed them in time. That was freaking rad. Oh, I can't believe that worked. Just need a tiny bit more thrust, tiny bit more speed. Please. I gotta go check how hot those motor drives are because I'm sure they're not cool. Yeah, that's too hot. That's way too hot. I know, liquid cooling is a thing, but it takes a lot of time to set up and I'm lazy. Let's go, Toby, let's go. Oh, that's so bad. My foil just landed on the rocks. Got some nice scratches on here.
So on that day, I was up on foil long enough to measure my speed, which tops out at around 4.8 meters per second, or 9.3 knots. The interesting thing about propeller choice for this project is, while I need the boat to be able to go this fast, it doesn't need to be optimized for this speed. While I'm up on foil, I don't need as much thrust from the boat since the foil is super efficient. Contender 25 is optimized for around 2.8 meters per second, which is probably right around the speed at which I need the most thrust to get up on the board. So this might actually be a really good propeller choice. However, if we look back at our motor telemetry data, we can see that we're only at a 27% duty cycle. This shows that the motors are not spinning fast enough to really reach their full power potential. That's why they're only getting up to 380 watts, even though they're rated for well over 1,000 watts. What this means is that these propellers are too big for how fast the motor wants them to spin. During the propeller competition, they didn't need to spin that fast because of the 400 watt limit, but now that we're trying to get more power, we need the props to spin faster with the same amount of torque. So to achieve this, I printed some 2-blade versions of these same propellers. Okay, so the first thing I'm gonna do is get some telemetry data to see if they're actually doing any more power. Doesn't really feel like it. Oh yeah. Wow, it's very capable. Downwind. Woohoo,
Look at that, I'm flying.
I'm really bad at isolating my variables here because I also turned up the max phase current. But if we pause it right at 35 amps, which is the max phase current from before, you can see that we're now doing 420 watts, which is about 30 watts more than before. So the two-bladed propellers helped a little bit, but not by much. It was increasing the max phase current that really helped, and at the expense of possibly burning out the motor. Now we're up to 800 watts with a 40% duty cycle. So the props are still too big, but oh well, this might be all the power we need.
Let's go, let's go. Oh. So close, come on. Okay, there we go. The props are just ventilating too much. Wow, now can I stand up? There's no way in hell. Oh. Go. Please, I'm begging you, please go. Woo! Those propellers just start to ventilate right when I get up. Oh, this is sick. Oh, going in a circle is actually really cool. I really want to stand on this thing. Go. No, keep going. Keep going, please. That was the best one yet. Please. Yeah. Stop ventilating. Woohoo! This thing is just going in a circle. This might be the best way to do it, honestly. Oh, fuck, this is awesome. Wow. Woo! Trying to get it to go in a straight line. That was fun. Yeah. Shit.
So at this point I was able to stand up, but the problem was that once I got up, the steep angle of the rope was lifting the props up out of the water.
Go.
And when the props come out of the water, they stop making thrust. The good thing about this is that it made learning to pump a necessity, but ultimately it was a problem I wanted to fix. One option would be to just make the rope longer, but this increases the hassle factor of the whole thing. So I opted to drop the motors down a bit and move them further back. This will also allow me to use one of the super efficient high aspect ratio propellers from the competition. By the way, if you want to access the CAD files from this video, including the boat hulls or any of the props from the competition, you can access them free at the Onshape link in the description. Onshape is a cloud-based CAD program that will allow you to edit my designs or create your own. Onshape is free for hobbyists, so click my link in the description to sign up. I printed these new gooseneck motor mounts out of PETG and resin printed some other parts to make it all more streamlined. I also decided to address the ESC cooling issues by cutting holes in the deck covers and putting cooling fans in there. And to keep splashes out, I resin printed these curved tubes. In the front, those screw right into the deck, and in the back, there's an 80mm fan in between the tube and the deck. The new gooseneck just goes right in where the motor's used to and screws in with thread-forming screws in the side. And then the motor goes onto the end of that and attaches in the same way. This thin resin print got glued in between the holes and the gooseneck to cover the phase wire channel and streamline things. With that, we were ready for another foil sesh. This day did not go very well. For some reason, one of my motors was having a hard time starting, so I had to hand start it like an old gas RC airplane engine.
Okay, they're going.
And then once it was going, it did not have enough power for me to get up. I think this might have been because of all the additional drag from the gooseneck motor mounts and all the extra weight I had added. The next day, I decided to test out the most efficient 3D printed propeller from the Propeller Design Contest. This is the one that Airshaper and Friendship Systems teamed up to design, with genetic machine learning algorithms and stuff like that. This prop did fine with the 400 watt power cap that we had during the contest, but I was pretty worried that it would break with more power. So that's why I decided to hit up PCBWay for their CNC machining services.
Let's see how these things look. They're heavy. Whoa. Wow, they sandblasted them too. That is dope. The quality is really good.
These props are made out of stainless steel, so they are super strong.
That's the real deal, man.
Honestly, they're way overkill for this project, but I'll also be using them in the future with more powerful motors. Not only can PCBWay make these same props for you, but they can also do 3D printing, sheet metal fabrication, injection molding, and of course, PCBA production. I've been using them to prototype printed circuit board assemblies for several projects that have been in the works for a long time. Hopefully, I'll be able to share them with you soon. Their website makes uploading your design files a breeze, and you can get an instant quote, well, instantly. Click on the PCBWay link in the description to explore how PCBWay can take your project to the next level. So now let's see if these PCBWay props can improve the performance of my boat.
So close. There we go. I can feel it accelerating. There we go. That's it. Yeah. Woohoo!
so now the boat made plenty of thrust to get me up. But it might not have only been the new props that did it. I had also increased the phase current yet again, this time to 56 amps. I'm still waiting for these motors to burn out. These new props seemed great, but it did make me wonder, would the resin printed ones have actually broken? Out of curiosity, I printed a pair to try out. So now I'm going to see if these resin printed propellers can even handle the torque. I'm really not sure. Wow, it works!
Wow, Formlabs resin printed props can pull me on a board. That's impressive, man.
I had been having issues with one of the motors not starting up correctly. I tried tweaking all sorts of settings, but nothing worked, so I ended up just changing it from FOC to normal BLDC mode. This is going to lose me a bit of efficiency, but oh well, at least the motors both start now. The BLDC is also louder, but this doesn't really matter since they're underwater.
It's kind of harder to get up on at full throttle now, because it's going too fast. It's getting up on foil too soon. There's something under the water there. That's weird. I don't like that. I can kind of steer the boat by which side I go to. Oh yeah, we're in a tight turn now. Woo-hoo-hoo! Whoa, too high, too high, too high. Holy shit. Holy shit, I'm going so fast. Oh.
At this point, I was able to stand up no problem. I don't know how well it would work with a heavier person, but for 150-pound me, it's perfect. I'm definitely a little sketched out by how much phase current I'm putting through these motors, but so far so good. I think that if they weren't operating underwater, they'd probably be burnt out by now, but luckily they get pretty good cooling under there.
Got it. Haha.
After getting to spend a good amount of time up on foil, I figured out that you don't even really need the two reins to steer. These help with steering when you're laying in the water, but once you're up you can really control the boat quite a bit just based on which side you're riding on. But you have to be careful because these turns are kind of like a positive feedback loop. The more you turn, the more it wants to turn, and then you get slingshotted out with a ton of speed.
Oh, you can really get slingshotted around. Oh, that's awesome.
At this point I was really able to start racking up some practice hours, and I started feeling a bit more comfortable on the board. Riding a foil board like this is such a great feeling. It's just so smooth. But at the same time, you really have to be on your toes because it's quite a balancing act. Other than the convenience factor, this little towboat probably doesn't really have any advantage over a traditional wakeboarding or wake surfing boat, since it doesn't make any wave that you can surf on. But there is something magical about riding a foil, which is super smooth, while getting pulled behind a quiet little electric boat, which is also really smooth. Paired together, it's just an all-around smooth experience, and it's super enjoyable. Of course, e-foil boards are probably more practical since you don't have to worry about the tow lines and stuff like that, but I would say my setup here has a few small advantages. For one, the board is a lot lighter since it doesn't have a motor and battery on it, and therefore it's more nimble and maneuverable. And also, since there's no motor on board, there's zero vibration. This allows you to really feel the hydrofoil cutting through the water. It's interesting, when I'm out in a turn to the side of the boat, it's buttery smooth, but when I get right behind the towboat, I can actually feel the foil cutting through the little tip vortices formed by the propellers. So you're really kinda tuned in to what's going on underwater. I think I'd probably still rather have an e-foil just for the convenience factor, but this thing does certainly have its advantages. Another big one is that you can drop the rope and practice pumping. You can't really do that with an e-foil because it's so heavy.
Okay, I'm gonna try pumping. Here we go. Woo! Woo, I'm doing it! I'm doing it, baby! Woo-hoo! Oh, yeah! Whoa! Come on! Oh! Oh yeah! I pump foiled! Oh, I did it! Come on, Toby! You got this! Okay, let's pump. Let's pump. Here we go. Yeah! We're going. Ah, come on! Up! Get up! Get up! Get up! Get up! Get up! Get up! Woo! Holy shit, that's such a workout. It's like the batteries might be dying. Man, those motors must be hot, or at least the stator must be hot. The rotors have a lot of water flowing over them. Whoa, seaweed. It's so shallow here. Okay, I'm gonna try pump foiling again. Come on, baby, come on, come on, come on, come on, come on. Let's go, pump harder, please, go. Woo. Oh, I'm doing it, I'm doing it, oh. Oh, my boat is so far away. So I just took the foil off and replaced it with some surf fins. I'm gonna try and get up on this. I don't even know if I'll be able to. It might be that the foil was creating enough lift and that kind of kept the board stable enough for me to stand up. I might not have that now, so we'll see. I'll give it a try. That's amazing. That goes to show the hydrofoil really does create a lot of lift, and it creates lift efficiently. I just could not build up enough speed on this thing. But I am wanting to try one more thing, and that is...
I thought it would be cool to get some shots of the foil underwater, so I printed this little streamlined mount for the Insta360 Go camera. I was quite surprised that it didn't really have a noticeable amount of drag. I could hardly tell it was on there. Another thing that surprised me is how much the mast is wiggling compared to the wing. The bolts are tight, but there's still quite a bit of play between the two. I designed another version of the mount with the camera looking straight up. Other than a nice view of my junk, this angle shows us how my legs start out in the water. I think this is actually really important because it offloads just enough weight from the board to be able to get it up on plane. When I would try to start out while kneeling on the board with my whole body weight, it would just get bogged down and not be able to build up any speed. Now you can see how the board leaves the water, and we're up on foil. Pretty cool. So these big high aspect ratio, high efficiency props were only getting up to just over 1,000 watts, and the duty cycle wasn't even hitting 40%. This indicates that these props are too big, so I decided to try out these little tiny ones. These are 2-bladed versions of Whalotron. The original version was a 5-bladed propeller, and it performed surprisingly well in the competition, considering its small diameter. So the question is, will the lower rotational resistance allow the RPM and duty cycle to get high enough to hit the max power that these motors are rated for?
I don't feel very much pull, but I'm getting up. Like, I didn't feel like they had a ton of low-end torque, but I got up just fine, so I don't know. We'll have to look and see what the data says. Hey, sorry if I'm scaring your fish.
Nah, you're all right, man. You're all right.
Just getting to 1200 watts, that's when the RPM gets higher. Wow, but the duty cycle is still pretty low. It's only at 48, 49%. That's actually really interesting. Why isn't the duty cycle going higher? Huh, so even these tiny little props are not getting the duty cycle up very high. I think what that really goes to show is that I could be running 6S instead of 12S, and it wouldn't really make much of a difference. I might get slightly more losses in the battery wires because we'd have higher current on the battery wire side, but on the motor side, even that lower voltage wouldn't really matter. Interesting. Okay, well, I'm gonna switch back to the bigger props. Yeah, with the bigger props, it's only getting up to like 1050 watts, 1060 watts. The duty cycle's at like 40%, so it's not that much lower. Well, I definitely kind of prefer the big props because I get more acceleration when I'm starting. That's kind of when it matters. So here's what I'm not totally sure about. Even though the big props make the motors output less power, maybe they're still making the motors output more thrust because the props are larger, so there's more mechanical efficiency in the water, you know? I'm not sure where that crossover point is. I would have to set the prop test boat back up to check, and I don't want to do that. Woo-hoo! Yeah. Man, it's so smooth. Woo-hoo! Look at that. What is that thing? There it is again. It's 2 plastic jugs tied onto a rope. It's connected to the bottom. Might have to take the submarine out here. Oh, shallow water. Get out of here. I gotta get out of here. Wow. Oh, carving feels so good. Woo-hoo! Oh, dirty water. Ew. Oh no, I got seaweed on the props. Well, I guess I better pump. Oh, this is some dirty water right here. Yeah, look at that. I went right through a cake of seaweed. There's another thing underwater. Those things are all over the place around here. Oh yeah.
I made it my goal to get good enough at pumping to be able to drop the rope and pump in a circle around the towboat, so that the camera in the back would be able to watch me go by, and you would all see how bad my technique is. After a few days of pump foil practice, I was eventually able to do a circle around the towboat. Super gratifying.
Woo!
The hydrofoil I have is pretty bottom shelf compared to some of the other ones out there, so I like to think that if I had a better one I could go much further. Once you kind of get the hang of it, the distance you can go is only limited by your fitness, so I gotta keep practicing. We'll see if I can ever beat the 1 minute mark with this foil. Right now my record is about 25 seconds, and the world record is well over 3 hours, so I got a ways to go. Pump foiling aside, this towboat is still super fun to surf behind, even if there's no wave to ride. It's just a very pleasant and mellow experience, similar to e-foiling. I was kind of starting to do some carve turns, but I think this boat probably doesn't have enough torque for someone who's really good to be able to carve really hard. That's pretty much it for this project. All in all, this has been super fun, and I hope to someday improve Toby to be even more capable. Thanks for watching, bye.
Toby is my best friend. We go down to the lake and jump in the water. He pulls me up and we ride around together.
Hell yeah.